Thoratec, the leader in mechanical circulatory support, introduces the HeartMate II left ventricular assist system. The HeartMate II is a small and quiet advanced blood pump designed for improved outcomes with a wide range of late-stage heart failure patients in need of reliable, long-term circulatory support. 60% smaller than currently approved implanted electric pulsatile LVADs and weighing only 400 grams, the HeartMate II incorporates precision engineering, a simple design, and 30 years of clinical experience. It is intended for long-term support as a bridge to transplant or for permanent implant known as destination therapy. The HeartMate II is implanted just below the heart. The flexible inflow cannula is attached to the apex of the left ventricle, and the outflow cannula is attached to the ascending aorta. The HeartMate II pumps blood from the weakened left ventricle to the aorta, the main artery feeding blood to the entire body. The flexible inflow cannula is designed for a wide range of patients, accommodating changes in anatomical position and allowing the inlet to remain centered in the ventricle. Both the inflow and outflow cannulae feature textured blood contacting surfaces clinically proven on the HeartMate XVE to be thrombo-resistant. Utilizing advanced continuous flow technology, the HeartMate II has only one moving part, a small spinning rotor that is capable of providing flow from 3 to 10 liters per minute, covering the full cardiac output of a healthy heart. As blood enters the pump, seen here in slow motion, it is straightened by the inlet stator veins prior to entering the path of the rotor. The rotor then spins the blood radially and propels it toward the outlet, where blood flow is straightened by the outlet stator veins. In typical operation, the pump runs from 8 to 10,000 RPM. The HeartMate II's patented ball and cup bearings are designed for long-term reliability and the minimization of blood damage. Pump flow is defined by two factors: pump speed and the pressure difference across the pump. For a fixed pressure difference across the pump, increasing the pump speed will increase pump flow. At a fixed pump speed, decreasing the pressure difference across the pump will increase pump flow. The simulated monitor tracings show the ventricular and aortic pressures of a patient. The blue waveform represents the pressure at the pump inlet, which is the left ventricular or LV pressure. The red waveform represents the pressure at the pump outlet, which is the aortic pressure. The difference between these two pressures, indicated by the vertical yellow bar, is the pressure difference across the pump. As can be seen, this difference varies over the cardiac cycle, with the largest difference occurring in ventricular diastole and the smallest pressure difference occurring during ventricular systole. For a given pump speed, in this case 8,000 RPM, the differential pressure defines what the flow through the pump will be at any given moment. In other words, for the example shown, during cardiac systole, the blue waveform, LV pressure, rises and is essentially identical to the red waveform, aortic pressure, which results in a decrease in the differential pressure. This is shown by the yellow bar becoming shorter. As the pump inlet and outlet pressures become more equalized, it becomes easier for the pump to propel blood forward, and therefore pump flow increases. This is shown by the increase in flow on the green waveform. The reverse is true during diastole at the same pump speed, where the blue waveform, inlet pressure, and red waveform, outlet pressure, separate, shown by the yellow bar becoming taller. When this occurs, the differential pressure rises, and the pump must overcome this increased pressure difference between LV and aortic pressure in order to propel blood forward, and therefore flow decreases. A parameter that can be used to describe the magnitude of pulsatile flow across the pump, relating to the degree of ventricular contractility, is referred to as the pulsatility index, or PI. The higher the PI value, the greater the fluctuations in flow over the cardiac cycle. In this example at 8,000 RPM, the PI is 5.7. For a given differential pressure, as the speed of the pump is increased, the flow through the pump increases and leads to greater ventricular unloading. As the pump performs more ventricular unloading, the left ventricle builds up less systolic pressure. This causes the blood flow pulsatility to decrease. This will be seen in the flatter pressure and flow curves as the pump speed is increased from 8,000 RPM to 10,000 RPM, with a corresponding decrease in the pulsatility index. As pump speed continues to increase and the left ventricle is further unloaded, the aortic valve opens less frequently. If the pump speed is increased high enough, in this case it occurs past 8,500 RPM, the ventricle is unloaded to the point where the ventricular pressure will not be high enough to open the aortic valve. In other words, the ventricular systolic pressure will not exceed aortic pressure. When this occurs, the left ventricular output will flow through the pump and the aortic valve will remain completely closed. As pump speed continues to increase and the ventricle is increasingly unloaded, the flow and pressure waveforms become flat as the pump takes over the cardiac output and the PI value becomes very small. The external system components of the HeartMate II include a small, flexible percutaneous cable that provides power to the pump and is designed to accommodate patient activity, the system controller, which controls pump operation, and the batteries, which may be conveniently worn in holsters and enable the patient to resume normal daily activities. The HeartMate II also shares the same equipment platform as the HeartMate XVE, which includes the PBU, system monitor, and display module. The HeartMate II is designed for reliable, long-term support. It incorporates precision engineering and over 30 years of clinical experience. Its small size and silent, vibration-free operation make it appropriate for a wider range of patients than currently approved devices. Its reduced size also contributes to a simpler and considerably shorter surgical procedure. The HeartMate II, an advanced left ventricular assist system designed for improved outcomes and improved quality of life.